Hey Fixers, and welcome to this video where I want to show you what are the applications of graphs in computer science. So you may know graphs. Graphs basically consists of vertices and edges, and edges connect vertices, and it's a very powerful abstraction, and it is used in many applications in computer science. So we have like different types of graphs. For example, this would be a directed graph because we have some edges that connect vertices. We also can have undirected graphs where basically all edges are bidirectional. So we have so one edge connects two vertices in both directions. And like this is one of many data structures in computer science. But as I said, it's a very powerful one, and it's used by the largest company on earth like Facebook, Google, Twitter, and Baidu, and Tencent, if you know them. So all of them are using graphs basically. So why do they use graphs? Yeah, because this powerful abstraction is it encodes a lot of information. So for example, you can encode a social network within a graph. So for example, here you have like one user, Obama. And here you have another user, Trump. And maybe they are even friends with each other, so they get a friendship relation. And for example, this one is you, for example, and most likely you are not friend with either Trump or Obama, but maybe you know someone who is a friend with Trump or Obama. Okay, so therefore you have like a certain hop distance. So if you would ask your friend, do you know someone who knows Trump directly, then he should point to this vertex. Maybe he doesn't even know that he has a friend who knows Trump or Obama. But if you have the data structure, if you have the social network, then of course you can analyze it and you can find out who knows a friend. So which of your friend knows Obama, which of your friend knows Trump, and so on. So you can do a lot of stuff with graphs, and it's very powerful abstraction. It's used by the largest company on earth. It's at the core basically of the largest company on earth, not only for social networks but also for web document graphs. So you can have, for example, in the web, you have like web documents. Here there are some text. For example, this would be a Wikipedia entry. And then you have another Wikipedia entry, also with some text. And this Wikipedia page is pointing to this Wikipedia page via a hyperlink. Okay? So, and basically, if you boil it down, the web is a huge graph. So maybe this Wikipedia page points to those two Wikipedia pages. This page points to this page as well. Maybe there are millions of other pages pointing to this page and pointing to each other and so on. So you get a huge document graph where documents point to each other. And of course, Google uses this graph representation to rank websites, to find the page rank of all the websites. And the page rank is like which page is highly referenced. For example, this one would have a relatively low page rank, say of 2, and this one could have a very high page rank, say of 10, for example. Yeah, so this means that in search results, this page is more trustworthy and it should appear at the top. And so basically, yeah, if I like summarize what are the applications of graphs in computer science, we have social networks, we have web graphs, we have biological networks where some different cells are in a neighboring relationship with other cells, for example, and you can model this with huge biological networks. You can have knowledge graphs where some pieces of knowledge are connected to other pieces of knowledge. For example, US president, the concept of US president is connected via an is relation to different persons, or has been relation to different persons like Jefferson, Obama, Trump, and so on. Okay, so you can represent knowledge in a huge graph as well. You can have product recommendation graph where you basically you have some products here. These are the products, and the products are vertices, and you have some people here, and those people have hairs, for example, and ears, and those people buy some products or have bought some products, and maybe he likes the product and maybe he hates this product. And he doesn't know about the other products. And this one, maybe he likes this product as well. So now you could conclude that, okay, those two persons, they are similar. Yeah, because they like the same product. So they are in a way, they are similar. So maybe, just maybe, this person likes this product or hates this product as well. Okay, and you can use this information for recommending some products that are likely to be bought by some persons. So you have this recommender systems, which are used, for example, at Amazon to find products to recommend to people. So, for example, you may know this people also bought at the bottom of Amazon. They are using a graph data structure to find out which products are often bought together. But not only that, I mean, we have applications in neural networks. So if you represent a neural network, you have the neurons that are connected to other neurons. So they have some massive connections. Like every neuron can have tens of thousands, even sometimes millions of connections to other neurons. So basically your brain is a huge graph, and you can represent this in your computer too. We have road networks where like vertices are different positions, and they are connected via roads. Okay, and the roads are the edges. So basically you can you can do some shortest path computation. For example, you have the city like in Germany we have Berlin, we have Stuttgart, and maybe there's a huge road connecting both. And then we have like a third city, like in Poland we have a city, and yeah, now the question is, what is the shortest distance? Maybe this one is 1,000 kilometers. Here we have also 1,000. And here we have also 1,000. And now your query is like in Google Maps. You know Google Maps. The query may be, what is the shortest path from Berlin to Stuttgart? And then, of course, it would not route you over Poland, because this one would be 2,000 kilometers. And here we have only 1,000 kilometers. So basically, you are also using it for road networks. And again, you see that very large companies such as Google use these road networks, use graphs to represent road networks. And then yet another big trend are blockchains. So you have blockchains, like you are going from one state to the other state. So basically, I mean, all those blocks in the blockchain. So we have the block, and each block stores some transactions that were done. So basically, this one is a graph as well. So it's a simple graph, but nonetheless, it's a graph. And because there may be some parallel branches going on. Okay, so this is like the nature of the blockchain. So we have some competing branches, and only one branch can win. So maybe at a certain point, this branch will be aborted, which means that all of those transactions are invalid, and then it moves back to this branch and goes into this direction. Okay, so you see, we also have very hot technologies like blockchain are also represented by huge graphs. Okay, so you have graphs are everywhere, and basically in the biggest companies, at the heart of the biggest companies, we have graphs. So not only that, like blockchains, also transaction networks like money flow. If you want to analyze the money flow, you have person A, like Alice, and then you have person B, like Bob, and then you have another person C, like Chris. And now maybe Alice has sent like $1,000 to Bob, and Bob has sent say $500 to Chris, and Chris has sent like $10 to Alice, for example. Then you can analyze, okay, so what is the average transaction flow? Where does all the money land in the end? So what is like the ultimate source of money? What is the ultimate so what is the contrary of source? Like, where does the money end up? So in which hands, and who are the rich people who own all the money? And so you can analyze this huge transactional network. And of course, sometimes they are not digitized, but actually many times they are. For example, big banks, they can digitize the money flow between users of their banks, and even governments can digitize the money flow. And then you also have the blockchain network. Here, the blockchain stores all transactions, so you can use these transactions to model the money flow in a certain time interval. For example, you can like model this based on the publicly available blockchain information. So you could just download all the transactions on the blockchain. You can create a huge network, a huge graph, and then analyze. So okay, from which Bitcoin wallet to which Bitcoin wallet we have some money flow going on. Okay, you see, those applications are everywhere. They are ubiquitous. Graphs are at the heart, at the center of many business models of large companies. So if you want to make yourself valuable to the marketplace, maybe earn some money with coding, then definitely learn about graphs. Graphs are very important, and I think in each coding interview they will ask you about graphs. And yeah, if you want to start earning money as a Python freelancer, then check out my free webinar. I give a link in the description below, and I show you like from 0 to $50 per hour. What do you have to do exactly? What are the exact steps to work yourself up the earning potential? Okay, thank you for listening, and see you in the next video. Bye.